Okay, so today is the second of our 2 days of review for those who have questions, and we have one. So this is now on homework 20. Which question?
Question number 5.
Question number 5. Fungus in the air?
Yeah.
Fungus in the air. Hold on. So let's see if we can do it without the answers. Oh, that still has the answers.
Yeah. I answered step 1, but I'm just stuck on step 2 right now.
All right. So let me read it. So the air in poultry processing plants often contains fungus spores. That's just disgusting. Inadequate ventilation can affect the health of the workers. The problem is most serious during the summer. To measure the presence of spores, air samples are pumped into an agar plate, whatever that means, and colony-forming units are counted after an incubation period. Here are data from 2 locations in the plant. The processes 37,000 turkeys per day, taken on 4 days in the summer. The units are CFUs per cubic fine. So we have the thing, day 1, day 2, day 3, day 4, and we have kilogram processing. Explain carefully why these are matched pair data. So you were okay with that part, right? Or was that your question? Okay, so you're okay with that one. So the sport count is clearly higher in the kill room. Much higher, much higher, much higher, much higher. Yeah, no question about it. Given 90% confidence interval to estimate how much higher. So what's the formula for a 90% confidence interval? Well, first of all, yeah.
Wait, confidence interval? Like which equation?
Yeah, I mean, what's the formula for it? That's exactly it. What's the formula for a confidence interval in this situation? Because we have multiple situations, right? We have means, we have proportions, we have 1, we have 2 samples, we have small sample, large sample, we have this, we have that, we have all the different locations, right? So which one is the one for this one?
Would it be the 2 sample proportions where the samples are large?
Okay, well,
like,
it is 2 samples, but it's not. These are not proportions. These are big numbers. These are not proportions. These are just straight up averages.
Oh.
Right. So this isn't a proportion example. This is the the mean example.
Oh, okay. So we're dealing with mean.
We're dealing with mean. We're dealing with averages. So what's the formula?
Sorry, I'm looking through my notes right now.
No problem. I mean, I can tell it to you, of course, but you looking it up and figuring it out will be better for you. Longer, but better.
Well, we don't know the standard deviation, so.
Well, you not know the standard deviations. That's correct.
Yeah. So we would use the one where it's 2 sample means when we don't know either one of the standard deviations.
Okay, and what is that formula?
X bar 1.
Good.
Or sample mean.
Good.
Minus X bar 2.
Yeah.
Yeah. And then plus or minus T star.
Good.
With square root of.
But 1 second. Isn't this matched pairs?
Matched pairs?
Right, this is a matched pair design, correct? That's what we did in step 1.
Yeah.
Matched pair design is not 2 samples. For a matched pair design, we take the difference. We had a special case for the matched pair. Don't you remember it?
I don't think so.
We look at the difference between them. So we're going to
first. Oh, is it the standard error? Oh, no.
No, nothing to do with standard error.
I'm confused. Okay.
We had all different situations. Of how to construct confidence intervals, how to do hypothesis testing, etc. One of them was for the matched pair situation. So there was a special formula for the matched pair. Do you recall that one?
I don't think so.
So the first thing we do is we first subtract top number minus bottom number for all 4 cases. This gives us 4 numbers, 4 differences.
Mhm.
And then we do a 1 sample t confidence interval for those. So it's going to be x bar plus or minus t s over the square root of n, our standard 1 sample one, but only after we subtract and find the differences.
So it's x bar plus or minus t star. Wait, what's on top? Sorry, I can't really see it.
S.
S. Oh, is that the sample
The
standard
sample
deviation?
standard deviation. We don't have the actual
Oh, okay.
deviation, as you mentioned.
Mm-hmm. So we're solving for that number.
Well, we got to first calculate those 4, and then take your average and standard deviation. That's going to be our x bar and our s, right?
Okay. Yeah.
Does that make sense from here on out?
Yeah. So for x bar, we're just, let me see. Are we just calculating for the kill room specifically?
No, it's kill room minus
Or-
processing. It's a math.
Oh, okay.
First step to subtract to give us the 4 differences.
Mm-hmm.
And then we
Okay,
use
that's where I
those
was
4 numbers,
Getting confused.
right? Then we use those 4 numbers to do it.
Okay.
Okay, so if
Yeah.
so you want to go ahead and do it, and then we'll come back in case you still have a question.
Yeah, that's
Okay.
fine.
Okay.
I'll see if I can do it right now on my own.
Yeah, 100%. So I'm going to pause. So I'm resuming the recording because we have a question. All right, so which one is it?
Number 6. I just wanted to make sure that the answer I chose is correct.
In an experiment to learn that substance M can help restore memory, the brains of 20 rats were treated to damage their memories. The rats were trained to run a maze. After a day, 10 rats were given M, and 7 of them succeeded in the maze. Only 2 of the 10 control rats were successful. The z-test for no difference against a higher proportion of the M group succeeds may be inaccurate because the populations are too small.
Is it because the number has to be higher than 10?
Well, so we have rules, right? We need
Yes.
number of successes and failures has to be large enough, correct?
Mm-hmm.
And we have how many successes? We have
Only 2 out of 10.
2 out of 10 is certainly not large enough.
Yeah.
And the populations are small as well. So which one of those is the better answer when they're both technically correct? So
The number has to be bigger than 10 though, right? Because 10 rats was a total.
right, but the number of successes and it's not the populations. I mean, the populations were small, but the number of successes and failures is too small. That should be it.
Okay.
That should be it. Of course, if it's wrong, let's see what it says. I like the mathy questions more, but let's see what it says. Can you hit submit?
I have to complete the whole thing to submit, and
Oh.
I have like 1 more due.
Oh crap. Okay. All right. Well, then you don't have to, turn off the sharing. But yeah, that's what I would say.
All right. Thank you.
Okay.